Okay, so to the next page, number 2, use of fundamental identities. So we learned about one way how to find the 6 trigonometric functions already. There's also the second way that we can use to find the 6 trigonometric functions. Let me list out the... Okay, so if you can go back to page 2 for the table, let me quickly just rewrite it in here to make sure we're on the same page. So we have sine theta equals to b over c, cosine of theta equals to a over c, tangent of theta equals to b over a. This one cosecant, secant, and cotangent, theta, theta, theta. Okay, so do you guys think there's any relationship between like any pair of them? Like, is there any purpose behind putting this one and this one together? What do you guys notice about them? Ish, yeah, they flipping like this. If you flip this one, you're gonna get this one. So in math, to make it like formal, we have the word reciprocal for it. You can simply understand it like flipping it. So with that saying, cosecant should be like 1 over what? Any guess? What should go underneath of this one? Sine, cosine, tangent, cotangent, or secant? 1 over sine, thank you. So this one in here, the first spot, would be sine of theta. Right. With the same logic, using this like ratios in here, what should I put in here? What should be the reciprocal of secant? Cosine theta, thank you. So we have cosine theta. Nice. And for the last one, what should be the reciprocal of cotangent? Tangent, nice. So it should be 1 over tangent. So in the future, if I give you sine, you can find me cosine by flipping it. If I give you cosine, you can find secant right away by flipping it. Okay. So the good trick for this one is that 1c would go with like one function that doesn't start with the c. So for these two, this one has a c. For these two, this one has a c. And for these two, this one will have a c. So you have like 2 c's together for saying if you like cannot recall what the reciprocal of cosine, for example, and you say something like cosecant in here, you automatically know that this is wrong because you have 2 c's in here. Okay, so that's a quick trick to remember these, or like double check on yourself. For quotients, it means division in here. Technically, it tells you that you grab 2 functions, divide them, you would get another function. So can anyone guess what will go on top and bottom on this one? Good, thank you. So we're gonna have sine over cosine. Why is it sine over cosine? If you notice, it would take the first one divided by the second one. Sine divided by cosine, meaning b over c, divided by a over c in here. We know that if we divide 2 fractions in here, we have to keep the first fraction. We multiply by the reciprocal of the second fraction. We flip this one. The c cancels out. We only have b over a left, and that's how we get tangent. Okay, so they did a lot of math for this one. That's how they come up with this convention to have tangent being sine over cosine. Okay, and with the same logic, using the second column in here, can anyone guess how, like, what the relationship between cotangent and any other like function? There we go. Good job. So we're gonna have cosine of theta over sine theta. And if you take a look at this one, sine over cosine, cosine over sine, these two are also the reciprocal of each other, which is why this one, again, is right. Okay, so everything should like link back to each other. The last one is harder a little bit. by Pythagorean theorem, PT, earlier, we know the relationship between a squared plus b squared equal to c squared. To double check on this one, if you square up this one, we're going to get something like b over c squared plus a over c squared. And then, let me erase this one. If we break it down, the parentheses, we're going to have something like b squared over c squared plus a squared over c squared. As they have the same denominator, we can combine the tops to get b squared plus a squared over c squared. And from the Pythagorean theorem, we know that a squared plus b squared equals to c squared. So we will have c squared over c squared, and as it's the same thing, it will be just 1. Okay? That's how we get this one being 1. And this relationship always holds true no matter what right triangle you add. Okay? And with the same logic, using like different pairs, we're going to have tangent squared plus 1 equal to secant squared, and so on with the other one. Okay? So now I want us to try on this problem. Example 2. I'm going to give you guys one function, and you guys have to help me find the other 4 functions. Or actually, this one I give you 2 functions already. And you guys have to help me find the other 4 missing numbers. But remember, you shouldn't draw the triangles just like how we did in the example 1. You have to keep playing around with it using the identities. You can use division in here. You can use flipping. But give it a try and let me know if it works, okay? Sorry. There. Better? So just to make sure we're on the right track, in here I'm going to put using the fundamental identities. Oh, I haven't given you a name for this one. Comma, we get. So in here, I just want to make sure that we're not going to go back to drawing like a right triangle and label them hypotenuse and adjacent opposite. We have to stick with the rules that we had earlier. And I'm going to give you like, okay, so there's one blank in the beginning of the page. It should be this word, fundamental identities. I forgot to like talk about that. So like the first line of like this page is said that by the relationship between sine, cosine, tangent, cosecant, secant, and cotangent, we also have the fundamental identities. That is the blank for this. Did anyone have a chance to figure out what cosecant in here equals to? Yeah? 3. How do you get 3? Right, thank you. So in here, the reciprocal of cosecant would be sine. We have 1 over 3, so the reciprocal of it would be 3 over 1, which is 3. How about secant? Anyone has the answer for secant? For this. Yes? Perfect. Okay, how do you get it? So.
Well, you do a reciprocal of
Okay, and then you multiply.
3 to
perfect. Yeah. And like you said, it is. Yeah. 2 times 2 on the bottom, which is 4. Yeah. My 4 is weird. Okay. Thank you. And then the last two. These two are a little bit tough. Like it's harder a little bit in the sense that you have to like, you have to recall the algebra trick. Like keep, flip, multiply. If we were to divide two fractions, we have to keep the first fraction multiply with the reciprocal of the second fraction. Okay. Anyone has the answer for tangent? Yeah. Okay, how do you get it?
Multiply by the reciprocal.
Right, of which one? Of the 1 over 3 or like 2 or 2 over 3?
2 over 3.
Nice. So with that saying, we're going to do sine divided by cosine. So we keep 1 over 3, but we will multiply with the reciprocal of cosine, which is 3 over square root of 2. The 3 cancels in here. And we're going to get something like 1 over 2 square root of 2. And then we multiply the top and bottom by square root of 2. And we should end up with square root of 2 over 4. Okay. So thank you. Right. And for the last spot in here, anyone's had any idea? I mean, we can do the long way, but there's a shortcut for cotangent, right? Like using the reciprocal identity. Anyone knows what it is? Any ideas for cotangent? Which one?
The tangent.
The tangent, right. If we flip the tangent, we should get something like 4 divided by square root of 2. How should we move on from there? Multiply by square root of 2, thank you. So then we're going to end up with 4 square root of 2 over 2. But then this 4 can cancel with this 2, so to find the answer for this one should just be 2 square root of 2. Okay. So let me give you guys like 3 minutes to try on this one. And again, I'm going to have some volunteers to fill up these missing like